She make me let my imperfections into all my pressure. Just to show me what's on the other side of inhibition. No apologies, my baby. I'm feeling so hurt. What's on the other side of inhibition? Ooh, I can't do it 'cause I'm feeling so bad.
Hello, hello. Happy Thursday, everybody. Make sure that gets paused. There we go. Oh, that's an ad. Okay. I'll just mute the ad, let it run. No, we don't have to hear it next time. How you guys doing today? Hopefully not too bad. So we've got a little bit of stuff to talk about today. We're going to finish up our chapter on lists and dictionaries. And then I was going to go over the solution to project 1. I think everyone got a chance to get that one in, right? Check and see. Uh-oh. Am I having stream trouble again? What is going on? Man, I'm refreshing. No, OBS says I'm okay. I didn't drop any frames. Connection's okay. Maybe it's just my view of it here. I don't know. Let's see, I'm just load back up here to chat, sorry. It's gotta be a second. Right. Take a look at project 1. Okay, this was our little hangman game here. Right. Alright, yeah, sorry, I think it's stable here. So we have this word list we can use. So let me grab that. Oh my goodness. Scroll over to the end. There we go. And let me fire up PyCharm. So we'll start with project 1, and then we'll jump into lists and dictionaries. We'll finish that one up. And then I was actually going to hold off on the next project till next week, if that's alright with you guys. Didn't have any big rush to get it assigned today. Let's see, yeah, that was our lists and dictionaries. Cool, so I'll start the new project here, project 1. And I'll do it in a new window so I can come back to this other one. Let's see, we stop our ads. Is it still? Yep. Alright, cool. We'll let that be for later. You guys have your coffee? Finished mine earlier today, so I moved on to the sparkling water. But I have a late night tonight, so I might switch back to coffee. I go make another pot. It's never too late. Well, maybe it is sometimes. Anyway, so I'll paste in the word list here. Right, and we know that's just some giant word list, so that's okay. So we're going to import random. So we can pick a random one. I think I even gave this one to you guys as an example at the end of a different class somewhere. I can't remember where that one was. But we'll have a random word equals my word list index of, and I want random.randint rand int. I want from 0 to the length of word list. And with this one, I actually want -1. Remember, because the rand int is going to give you inclusive, and there's no index at that last value. So it'll occasionally crash if you're not careful about that. Sorry, one second. Okay, so that'll give us a random word, right? And I think that's what we did before. I could go check. I guess we could go check. Hopefully you guys go out and actually check on the GitHub here. Check on the GitHub. Check the examples in GitHub if you ever want to look back at the code that we did. It's called word, I call it word underscore list. There we go, word underscore list. It's really searchable, which is cool. Nope, if you remember to do the right search there. There we go. Yeah, when we were doing functions, I'd given you that word list there, getting a random one here. So that should have been nothing new there, hopefully. Okay, so we got a random word. We're going to do this every time, right? So we're going to have something like play again equals a yes, and while play again equals a yes. Let's keep doing this. The first thing we do when we play is we pick a random word. Right? Oh, excuse me, I didn't get the mute in time. Hopefully that didn't blow your ears out. Alright, so what we need to do, we're going to be building this right with our functions. So we're going to guess a letter in a function, replace the underscores in a function, and add body parts to the hanging man. Right, build the gallows here, use a function, takes a number of body parts. Build our gallows out. So this is what, print hangman or something. We can do that one. We'll say, actually I'll leave word list at the top, that's fine. Oh, maybe I'll put it down here. So we'll define print hanging man. That takes a, what, number of incorrect guesses or something? Number of incorrect guesses. And, ooh, that looks funny. Let's try pasting in a notepad here. Nope, notepad's bad. Alright, how did I get it to copy paste last time? I feel like it's worked before. Yeah, that's terrible. Okay. And it didn't work in Notepad either? What did I get in Notepad? Ah, here we go. I just need to space it all a little bit. There we go. Something like that, right? Is that off by one, maybe? I guess it doesn't line up perfect. That's okay. So we'll have, depending on the number of incorrect guesses, a different print each time, right? And this is where it gets a little funny, because, man, didn't I copy that right out of Notepad? Notepad. Wow. So give me some weird... Oh, those are the spaces from the other one. That's what it is. Okay. That's interesting. Alright, and that's like the little hang on that or something, right? That's not the prettiest string I've ever done, but it ought to do. Right, so this first line gets printed no matter what. And there's lots of ways you could have done this, not too big of a deal either way or the other. And then we're going to print that second line. No matter what. Really? No, tab in. I don't want to tab them all in. Maybe I want to tab them all in. And then we're going to print this character. Right, and I'm going to change the end equal to this. And then we can say if the number of incorrect guesses is greater than 0, then I want to print a bunch of spaces. How many spaces did I have here? That, and an O, oops, a quote. Right, the head there. Then an O or 0, I forget. Right, so we're going to print the head in that case. Sure. Right, and then if not, right, I just want to print, I just want to go down a line. So this is kind of convoluted here. I'm not a big fan of trying to do it this way, which you could in a single function this way. Again, that's a little awkward, right? Trying to build out each individual body part inside of if. So we could. It's not the end of the world to do that. But like we have to check to see if we get an arm first, and then we do the body and that, and it just feels awkward here. So let's abandon this, okay? No shame in abandoning a bad, difficult looking proposition here. Okay, so let's just take it all out. So we can say if number of incorrect guesses is 6 equals 6, oops, guesses, then we're going to print the whole thing. Right, and just each one of these goes on its own line. Sure, we could do that. Or we could build out this string. Right, let's see if we can build that out. You can use one of these funny triple quote strings to make a multi-line string. I think we briefly talked about multi-line strings, and then the backslash needs to be escaped then. Right? So we would say we don't print this whole gallows thing here, and we'd have another one. Right, there's his head. Maybe I did the 0. No. Yeah, the 0's okay, sure. And then all the dashes here. No, we didn't have the dashes there. We have one more row, all the dashes, and then this one had, I don't know, the little rope or something. All right, I'm having too much fun with the ASCII art. I apologize. So if it's 6, we get 1, 2, 3, 4, 5, 6. We get all the body parts. Right? We'd have, this is our, what, our gallows equals that multi-line string. Sure, we could do that. And actually, when you do multi-line strings, now they can be tabbed back. It's this crazy, crazy format. But they're helpful if you want this big, funny multi-line string. Right, and then we would say we could print gallows. Sure. Elif number equals 5. We'll do the same thing. We'll declare the gallows and print it, but now we leave off a leg. Right, and now this gets a little bit easier. We just copy paste this sort of stuff. I'm pretty sure all this needs to be indented. You know what? Let's leave it here because we'll see what it does, and maybe it's not the end of the world. All right, so 5, and then 4, right, and then 3, and then 2. So I'm feeling a little bit bad that we have some like redundant code in here, but it's just ASCII art, so I don't feel too bad about it. 1 is just the head, right, and then a 0. If it equals 0, we print that. Okay, so we should be able to print gallows. So let's actually wait on that for a second. We'll make sure our print gallows works. Right, so print our hanging man. And let's do a loop for it, right? So we'll say for number in range 7, because I want it from 0 to 6, so I gotta go past 1. We'll print the gallows and see what we get. Look at that. Little hangymans. Oh yeah, so that one's off the most, and the other ones are tabbed in. So they definitely are tabbed, so maybe we want to fix that. We can do that now that we're done with our copy paste, I guess. So if you just grab multiple lines, you can do a shift tab, we'll bring them back. Okay, let's run that again. See if we get our gallows. All right, yeah, that's not looking so bad. All right, so we have a function for printing our hanging man. You guys with me so far? Feeling okay? So that was the first function. Right, then we have the random word, and then we're going to ask the user to guess a letter. If the word is in the word, we're going to replace the underscores with the letter in another function. And if not, we'll add body parts, keep them guessing. Don't let them guess again. If they win, lose, or draw, so if they want to play again. So we need a function for guess a letter. So every time this game starts, right, we need to have a list of letters guessed. Right, starts off blank because we don't know what it is here. Right, and sure, we can pick the random word and then say that either one's fine. Right, and then we're going to have the we'll call it the hidden word equals Now what I want is I want a bunch of underscores, right? And I want as many of them as the length of random word. Remember, we can do this arithmetic with strings because it's crazy. So I can string together as many of these as I want based on however long the random word is. It'll give me all the dashes. Okay. Then we're going to ask the user to guess a letter. Right. So we said we got to do that in the function. So this is guess a letter. And if they're not allowed to guess duplicates, we need to tell them which letters we've guessed. Right. Letters guessed. Right. So we need to ask them for a letter. Right, so we should get the letter is an input of guess a letter. Right, and then we might want to do some checking. Right, we've saw a couple of cool things with strings. So if we say, I don't know, if a couple of cases that'll make this bad, right? If it's not an alpha character, we can check if letter dot is alpha, right? So it's actually a letter, not the numbers or like the characters 1, 2, 3, 4, 5, 6, 7, 8, 9, right? We don't want one of those, right? Yeah, so if the letter is alpha, or if the length is long, right? So if the length of letter, if they gave me more than 1, greater than 1, then it's no good, or it's not is alpha, right? Not, so like a white space is not alphanumeric, or numbers is not, right? So this sort of, not that one. And really, I guess that's a while. We could say while it's greater than 1, or it's not alphanumeric, or letter is in the letters guessed. We'll just tell them again, guess again. And you could give them specific messages if you want. They could be very nice and say, okay, hey, it's got to be one letter, or it has to be alphanumeric, or you've already guessed that one. Right? We're just going to keep them in there. And then we're going to take letters guessed, and we're going to append the letter. So once we get out of this loop, I know that all of these are false, that it is a single character, and it is alphanumeric, and it is not in, because we're all of these must be false for the whole thing to be false. So you got to be a little bit careful how you're using your ors or your ands. In this case, we want, if any one of these is true, the whole thing is bad. Keep them in the loop. Right, so that'll guess a letter and doesn't allow them to pick repeats. Have them guess again. Okay, and I guess, okay, so it says we should tell them they already guessed that letter. So I guess from here then we could be more specific if we wanted, and then tell them you already guessed that or something. So we could say if letter is in, print, you already guessed that letter. Sure. And then ask them to guess a letter again. Or we could even check, no, sure, why not? If not letters alpha, print, you can only guess letters, right? And we probably also want to take this to lowercase, right? Because we only want lowercase input. You got to be careful when we're doing that. Otherwise, we might run into trouble with this letters guessed in the other word. And we can even check here if length of the letter is greater than 1. We'll print, please enter a single letter. Right, so sure, we got some messages here for them in that while loop to tell them. So now I feel a little better about it. Does that make sense? So we're going to print the hidden word, and then we're going to ask them to guess a letter. So letter is guess a letter. Oh, actually, we don't even have that, right? We just call guess a letter. Right? Guess a letter given the letters guessed. And because this list is mutable, we can modify the list argument that's been passed to us. Oh, why is it's complaining? Oh, because we're doing that shadowing. That's okay. We're using it out here, and it doesn't like that we're calling it the same thing. That's okay. So if I hand them letters guessed, right, we can modify that list. I guess we want the last letter guessed, though. So maybe we should return the letter as well. Sure, we'll do that. We'll return the letter. Okay, so now I'll have the letter is that, And then I can check if letter is in the random word, then I'm correct, right? This means guessed correct. Else, oh, we need to track how many guesses we've done wrong so far, right? Number of incorrect guesses. Every time this starts off, right at the beginning of our loop here, right, every time we want to play again, it starts at 0. So if they're wrong, so the else case here, right, we're going to take plus equals 1, and then we'll print the hanging man given that number of guesses. Right? And then all of this, so if they are right, then what we want to do is we want to go and we want to update the hidden word. So there's a couple ways to do this. I'm fond of updating it because I think that works out pretty nice. So we can go through and we want to find this letter inside the random word. So I know it's there. And then at the index that it's at, I want to replace the hidden word with this one here. That's kind of a bit of a work, isn't it? So we're trying to do this in a function, right? So if the letter's in the word, replace the underscores in another function. Sure. So, well, if that's correct, then we need to call another function. We'll have this as replace letters in hidden word. And so, sure, you're going to need to give me the string, which is the hidden word, and then the string, which is the random word. And I'm also going to need the letters guessed. So if I know what the hidden word is that has all the underscores in it, I know what the random word is. You know what? Let's skip that. You don't even need to give me the hidden word, right? Because we can figure it out, right? So if I know what the random word is, and I know what letters you've guessed, we're going to build out a string here. So this is our hidden word is equal to this, and now we're going to go for every letter in the random word. If the letter is in the letters guessed, I'm going to take my hidden word and I'm going to add the letter because it's been guessed, so I'll add the letter. If it's not been guessed, I'm going to take my hidden word and I'm going to add an underscore. I'm done, I can return the hidden word. Right, so just one letter at a time in the random word, we'll either put the actual letter in if we've guessed it or an underscore. I like that. So now we don't even need to save hidden word, right? We can just print replace letters in hidden word, given the random word and the letters guessed. We don't even have to do that. That's cool. Right? All right, so maybe you can replace letters. Maybe that's the wrong thing. So I'm going to rename this one here. I don't like how that's named now. This is show hidden word, or I don't know, hidden word. Create hidden word. I don't know. Because we're not replacing. Oh, there we go. Create hidden word. Okay, so we're going to create the hidden word with the random word and the letters guessed. And we're going to print it right out because I don't even need to save it ever. And I'll get the letter they guessed. If it's in there, good. Nothing happens, right? We just keep going because we're going to print the hidden word again. So all of this happens again, right? So we're saying while, and we need to be tracking the number of incorrect guesses is less than 6. We're going to do all this, right? Because you get 6 guesses. So really we don't care if it's in, we're going to do the exact same thing over and over and over again. We only really care about if it's not in. Right, and we can get rid of that else case. If it's not in, we'll print the hanging man. Otherwise we'll print the hidden word. Is that fair? I'm not upsetting you. Like we're sort of replacing underscores. I don't know if that's we could do the other way around with like string slicing, but replacing might be a little tricky, right? You guys feeling okay with that? I didn't cheat. Where's the rubric for this? Don't I have a rubric for this? Didn't I give you guys a rubric for this? Now I'm confused. Give me 1 second. Let me pull this up here and go back. I really thought I had a rubric. Oh, there it is. Okay, I was just in a weird view. I was in the edit view. There it is. So 6 incorrect guesses, so you lose. Got it. Function to print the gallows and hangman. Got it. Function to guess, let the user guess the letter. Got it. Function to let them don't let them repeat. Got it. Function to replace the blanks with the guessed letter. Sure, replacing blanks with the guessed letter, and ask them to play again when they're done. So the other thing we're not doing though is how do we win? Right? How do we know when we're done? Here. Right? So what I'm actually going to do, I'm going to move this one up here to do it first before we guess a letter. And then I'm actually going to keep that hidden word. I do want to end up keeping it. I want to keep my hidden word is the create hidden word. Okay. And we might as well print it, right? That's fine. We can print the hidden word after. Right, just to let them, even whether or not we print the gallows or not, we'll print the hidden word again here. You said I cheated? Is that, I'm sorry, I forgot to be watching chat. So I cheated by not having to do the string slicing? Because I'm just building out the underscores here every time. We can do it either way, I don't mind. Oh, I had a rubric. Okay. All right. Thank you. Thank you. All right. So then the other condition that we have, we want to stop the loop. We want this to run while this is true. And there is an underscore in hidden word. If there's not an underscore in the hidden word, I want the loop to stop. This will be false, and I and together anything with false, the whole thing becomes false. My loop will stop. Right, so by tracking that hidden word here, instead of just printing it, if I have it tracked here, I can make sure there's an underscore. And I could just go build it again, but I feel a little bad doing that. Oh, we should, I'm sorry, we should do this up here too. That should happen right here. Okay, there we go. Okay, and then once all that's done, we'll ask them if they want to play again. So play again equals an input of want to play again, and then, like, you know, just prompt them like add in a y or no, and I'm just going to lowercase that while I'm here because I'm only comparing it to the lowercase up here. Okay, so we don't need that printing of the hanging man, right? Should we print the guy, the gallows, at 0 when we start so they know that it's hangman, or just print the blanks? Should we, I mean, we could always print the gallows, I don't know. Alright, let's take a look, let's see if it runs. Alright, so we get a couple blanks, looks like 7 blanks, is it? There, let me zoom that in, sorry. There we go, 7 blanks. So how about let's do some vowels. So A, not an A, how about an E? Alright, there's an E in there, an I, an O, okay, a U, uh-oh, a Y? Nope, okay. Well, that was 4 guesses wrong. How about like L or R, S? I'm so bad at this game. Let's see, we almost hung our poor man. Hanged the man. Sorry, you don't get hunged, you get hanged. C? Is it process? Process. Alright, look at that, we won. Do you want to play again? Yeah, let's play again. Alright, this one looks like it is 8 letters. Alright, let's do some vowels. A, E, I, O, U, Y. Okay, we got a couple. Only 3 misses there. R, L, S, T. Strategy. There we go. Alright, we won. That was pretty good. Let's try again. 4 letters. I find the 4-letter words are actually really hard. Like A, E. Is it bear? Nope. R, tear, eat, feet, meat, beat. Oh, we already guessed that one. What's another EAT word? Seat? Oh, seat. Thank you. You guys are good at this. All right, let's play again. I want to make sure I can actually lose here. I guess I should just lose on purpose. A, B, C, D, E, F, G. Oh, we hung the man. It didn't even tell me what the word was. Maybe we want to tell him what the word was at the end, right? Right, maybe we should print the random word. The word was random word. Okay, because I don't know what word that was, so that's okay. So it looks like I can lose. That was the whole point, right? A, B, C, D, E, F, G, H. Customer. Oh yeah, yep, customer. I should have gotten that one, obviously. And no, we don't want to play again. Alright, how's that one feel for Hangman? You guys do okay? Not too terrible. Hopefully it was a fun chance to play with some functions. And again, designing functions is tricky. It's definitely an art. Like, how do we break things down and do that functional decomposition and decide what should belong in a function, what should go elsewhere, that sort of thing. Like, I don't know. I sort of cheated on this one, but I imagine it's probably the easiest way to go about it instead of trying to say, like, if the number of body parts was 3, print this, and then if it was 2, print this and not that. And that just sounds really terrible. And it would have been less lines, but not any easier, and probably even harder to read. So, like, in terms of readability, I'm happy with this. I prefer it that way, I think. I don't know why I started with 6 either, and went down to 0. Alright, then guessing a letter, creating a hidden word. Yeah. That one go okay for you guys? I think I'm finally turning the bend on the cold here, or either that or the cold medicine's really working, because I'm feeling halfway decent, which is nice. So hopefully this weekend I'll get a chance to get caught up on everything and get your midterms graded, get these projects done graded. But I'm not going to have another project for you guys to start till next week, because take a look at our schedule here. Our schedule. We're going to finish up lists and dictionaries today. And then I'll post a quiz for you guys as well. Here we go. We're going to come to classes, and classes will be our next project. Dealing with classes, and then hopefully we'll have one last little project with files, and I want to give you your final project this week so that you've got time, but like I don't expect you to have to do it over final break, but that way you'll have the 4 weeks to do it even without Thanksgiving break. So 1, 2, 3, and let's do then the 22nd. Oh, we have a big gap there. Wow. Did I get the right time in there? Why is 6 p.m.? Oh, they redid how we are doing our finals for remote. I forgot. That's why it's so far different. So we got a big gap. So even if we don't get it till, it gives you a month if you get it this week. So we'll do a project this week. It'll be due this week. You'll get a project on files. I can take that one like through December 1st, but I want to give you, in case you want an early start on that, if you're an early start kind of person, I'll give you the final project that week. Alright, so it's not going to be using recursion, so that should be okay. But we'll do a project on classes and a project on files. And files will use these exceptions. And we don't do a whole lot with modules. It's just an interesting topic for you guys. So I think that'll go well. Alright, any questions? You guys are doing well. We are almost done with halfway. Oh, a dad joke. Alright, you got it. I just got a good one from a friend of mine. Where is it here? That's right. You just sent it to me. Yes. Did you know Cardi B has a sister, and she's actually like an athletic trainer. She's not big into singing or anything. Yeah, her name's Cardi O. You're welcome for that one. All right. So let's go back to our lists and dictionaries here. Okay, actually, you know what? I've got, this is already really big with all the list stuff. So let me do another project here. We'll just do just a chapter 8 dictionaries. Let's see, I'll close out project 1. Throw that one in GitHub for you guys. Alright, so we'll do just the dictionaries here. This one. So how far did we get? We did single lists. Okay. So dictionaries, it's fine. One title 1. So here's project 1. Oops, and I don't want all that chapter 8 stuff. Let's just do project 1. So you can be selective on what you commit. I mean, I only want to change those ones for this commit. And then I'll have like the dictionaries project started. Or I can just leave it. You know, we can do those ones after we're done. Okay. Cool. Pull this up here. My other laptop has been commandeered by my children. So I've got to pull up, make sure I'm not missing anything for you here. All right. So our dictionaries, again, the idea is that it is a mapping type. So we have a key and an associated value. Keys have to be unique, right? Because the way that you access things is by key, but the way that you access them is also how you update them and add them. They're all kind of built in, all in one. So if we were to make a grades dictionary, and again we use the curly braces here, we can give it key value pairs right away when we make it. So I can say Eric has a grade of, say, 97, 98, sure. Right, so, I'm sorry, it's a colon, so 97. 97, comma. You do comma separated key and value pairs if you want to hard code a dictionary. And we'll have my son Jeb. Jeb has been not following along on Twitch like I thought he would. I thought he'd be much more interested in Python coding, but that's okay. He's been doing some of it on Khan Academy and what's it called? Code Combat. And you can do Python coding in that too. And it's probably much more interesting than watching me, but I feel like they don't teach you quite as much. But that's okay. I can have opinions. Right, so we're in the grades dictionary, right? Using this, here's the key, colon, here's the value. So it's key, colon, value. Then we can also go in grades, and we can say, okay, key of, instead of index of, we read that as key of. Reads as key of, right? So key of, and let's add, we'll add my daughter Journey. We'll add her in. She wanted to also watch, but she'll watch a little bit, but I don't know, she gets bored of it quick. It's hard to sit and watch a whole lecture. So we'll say maybe she's not doing so well. Maybe she's only doing like 86% or so, right? I'm sorry, not the colon. So we'll say she equals 86. So grades key of Journey, we're assigning a value of 86 that will either add or update. So that same notation is for add or update. Hopefully none of this is new, right? Because we've talked about dictionaries all the way back in chapter 3. I really need some of this more caffeine. Let me grab one of these. You can drink like 2 energy drinks a day, right? Plus your coffee, if you're not feeling. Maybe that's why I'm feeling a lot better. That might be why. Okay. Now, a lot of you on the quiz, I had a question. It's not a trick question. I don't feel like it's a trick question. It said you can do lookups for a value in a dictionary using the in operator. So I could say, hey, if the Eric is in grades, do something. But I'm not looking up a value here. What this is doing is looking up a key. So several of you lost points on that, and I'm going to try and not feel too bad about it because I don't think it's a trick question. right? I think, why is it complaining now? Oh. Okay, that's weird. Anyway, you can do key lookups, but you can't do value lookups using the in operator of the dictionary here. But this is helpful, right? I can say if that's already there, let's go do something, right? We'll print Eric. Oh, we'll print grades key of Eric, which will be my associated value, which is the score. So it should print a 97. Right, there we go. Cool. So we had this lab when we did the dice rolling. Do you guys remember that one? I suggested you use a dictionary for it. So we said, I didn't show you that one, did I? I don't think I solved that one yet. But I wanted to show it to you because I thought it was an interesting way of using a dictionary. So if we have in the sides, number of sides is an int of an input. How many sides on your die? And then we had the number of rolls. Number of rolls is an int of an input. Times should we roll the dice? Or no. So and we also had the number of dice to roll, right? Number of dice to roll. There we go. Was an int of an input. How many dice should we roll? And then how many times should we do this, right? Because we're going to try and simulate and see how random Python actually was. So let's import random here. Now, just with that information, I can create a dictionary of sums, right? Because I wanted the sums of the number of dice each time. And we're going to do it this many times to see if we get a good, nice distribution. Right, so we're going to start a dictionary. And then I want to say for sum in range. And now I want to start at the number of dice to roll. The number of dice that I'm rolling is the minimum I can get, because a die will at least roll a 1. Right? And I want to go up to the number of dice to roll times the number of sides. That's the maximum roll. But because range doesn't give that to me, I also then want to add 1. Right? So that will give me all the possible sums that I could get here. And I'll take sums, and I'm going to say key of sum, and I'm going to assign it a value of 0, because it has been rolled 0 times. Right? So that will set up an empty dictionary now, so I can just print that dictionary, print sums, and it should start at the number of dice to roll, go up to the number of dice times the number of sides. Right, so if we have a 6-sided die and we roll 6 of them, I should be able to get from 6 to 36. Right, from 6 all the way up to 36. On and on and on. Okay? So that's good so far. So then what we're going to do, we actually wanted to simulate. So for every roll, right, so for roll in range, number of rolls. Now this is roll number. We don't actually really care, but that's okay. We're not going to use it. So we're going to use a random number, right? So based on the number of sides. So this is going to now be for die in dice to roll, number of dice to roll. Now I have a value, right? So I'm going to be summing here. So I'm going to have a sum is 0. And for every die I'm going to roll, I'm going to take sum and I'm going to add to it random.randint from 1 to sides on the die. Right, and I just do that for every die I'm supposed to roll. Keep on going. Then when I'm done, whatever that sum is, I want to go to my sums dictionary, key of that sum, and I want to add 1 to it. Because now I've seen that sum that many times. And it'll do for every time I'm supposed to roll. And then when I'm done, I want to print. So I actually want to do this, and I want to print it out in order. So I want to say for sum in sums, right, that should give me every key here. I want to print the sum, this, and the associated value. So sums, key of sum. Right, that'll give me the value associated with the key of sum. So let's take a 6-sided die, we'll roll 6 dice, and let's do it, say, 100 times. Ooh, uh-oh. Where did I do that wrong? Oh, and range. There we go. Forgot to range. Range the number of dice to roll. Try it again. So 6-sided die, let's roll 6 of them, let's do it 100 times. And we'll see, it's kind of hard to see the distribution here. Right, we kind of see it here. So what I want to do now, I'm actually going to change this. So I'm not going to print this as a number. I'm going to print a star character that many times to build out a little picture of it. So a 6-sided die, 6 of them. Let's do 200 rolls. And we see it's a little like histogram style chart. And we see it's mostly a normal distribution. Not exactly perfectly normal, but mostly normal here. Right, and as we increase that, if we do more than 200, right, let's do, say, let's do 600. Right, we're still not getting a 36. That's a 1 in 6 chance times 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 a 1 in 6 chance. What is 1 divided by 6 to the 6th? Divided by 6 to the 6th? I can't read scientific notation. You guys make me sad. To the -5, so move it over 5 decimal places. There's 1, and then with 4 zeros. Why does it? Can I just have a standard? 1 divided by 6 to the. Where's my to the power? Oh, I don't even have that. Okay, forget it. It's a small number, right? Okay. So we can use a dictionary, right, this way, by pre-building it. Okay, going through, setting up all the values. We're in here. Great. Right. Other cool things we can do with dictionaries. You can remove. It has a pop notation to remove, just like we could remove out of a list. Pop would go by index. Remember, there's no indexes in dictionaries. So if you wanted to, up in my dictionary here, if I wanted to remove somebody here, I could now take myself out of the dictionary. So we'll take grades.pop key of Eric. Now when I print my grades dictionary, I'll be gone. Right, gone. So pop will remove. So it removes the key and value. Okay. Other cool things you can do if you're trying to get a value out of a dictionary but you don't know it exists, right? Usually you'd use this in notation. You say, hey, if the value is in here, great, do something, and then else. But again, depending on the dictionary here, maybe we'll say, hey, if I don't have the key, let me give you back no score. So I can ask for a name. So we'll say name is an input. I'd like enter a name, and then I want to get the score out. So I'm going to print score for name is grades key of name. Maybe a colon here, right? Now this will work if I enter a name that's in the dictionary. Right? If I enter Jeb, it'll work. But if I enter a name that's not in the dictionary, if I enter a daughter like Vivi, if I wanted to see her score, it crashes on me, and that's no good. So instead of this notation, if you are not sure if it's in the dictionary, you can use this get. And get says, give me a key. Okay, so sure, I'll give you the key of name, but it also has a default. So if I don't get a value back, say if that's not present, just give me a 0. Sort of like that shorthand. Right? So instead of saying an if name is in, give me the name, else 0, right? We just do it all in one line here with the get. So you can give me any name you want, and I'll just, if it's not in the dictionary, it's 0. because I don't have a grade for them. And again, maybe that's not a good use case. Maybe you want to say, hey, specifically what it is, but you got that option. So there's methods and dictionaries, which is cool. And a couple other fun things we can do. So this is just taking each key out at a time, but what if we changed this up, and what if we said, okay, I don't want to put in some defaults. I don't want to put in zeros here. I just want to add them as I find them. So if sum is in sums, I'll add 1 to it. If it's not, right, then sums key of sum equals 1. That's the first time I've seen it. So I'm only going to be adding the values that I have found. And maybe that's more interesting if we're rolling like 5,000 dice with 5,000 sides, because we're not going to get very many values, right? But now when I run this, right, let's do our 6 dice with 6 sides. Let's do it 100 times. My printout's not in order. Right, this is all mixed up here. And now order has never been guaranteed, so like you shouldn't expect it to work. So the right thing that you want to do here is you want to say, I want the sums.keys. So this will give you the list of keys here. And then if I want them in a sorted fashion, I can call, say I want a sorted list of keys. So keys by itself is not actually a list. And this is kind of a funny thing. It looks a whole lot like a list, but it's not actually a list. You can't call .sort on it. It's a little silly. But if we do like 100 sides on my dice, we roll 100 different dice, and we want to do it 10,000 times. Right? We're only getting out the values that actually were landed on. That's a bunch of values here, but they're in order because we got a sorted collection of them here. So just a choice. If you don't want to have to go preload it here, so it's 6 dice. Let's do that 1,000 times or so. Right now, so if we still don't have a 36, there's still no 6. We're still missing some. So depending on what you're doing, if you don't want all the values showing as zeros, if you only want the ones that were present, we could do this here. Right, that's a choice. And you can use this .keys notation. Then you can also get the items out. Right, if I wanted the, which one was rolled the most. Right, we will say the sum rolled most often. And I could get the max of my sums.values. So values will give you all the values out, .values. Right, so we could do some quick, make Python do some math for us here. It's 13. Right, I don't even have to go and look and see. Oh, that's not the sum. I'm sorry. That is the most times that one was rolled. I'm sorry. I'm backwards here. This is finding the value there. This is the max value. So not the sum, but what is it? So like out of all of the sums, this one was rolled 13 times. The most common sum was found 13 times, or something like that. Sure. Okay. Right, so you can get values. You can also get items out, and items will give you key value pairs. That one can be useful if you want both values and you don't want to have to use this notation. I'm not as fond of items. All right, and then we get to some crazy stuff. We get to two-dimensional data structures. This idea that I can put a dictionary inside of a dictionary. It's kind of neat. Or you could put a list inside of a list. So lists inside a list is actually pretty common. A dictionary inside of a dictionary is not quite as common. I mean, you can, but you start to get confusing. Yeah, this is PyCharm. So, sorry, I'm way far back here. I hope you guys can still hear me. My back's been bothering me again. There we go. Maybe I'll use my little backboard here. There we go. Ooh, that's nice. Okay. So if I were to make a list here, And we'll call this one a, what do we want to call this one? How about our grid equals a list? No, we did two-dimensional list, didn't we? I swear we did. We had a list to list, didn't we? Did I not do that? Am I making that up? We had to put new lists inside of lists? I made it up. We didn't do it. Okay, so if I have a grid here, and yeah, I don't know about a massage chair. I think those real good, nice chairs with lumbar support would probably be better. But this thing was cheap, and I can lay on the floor too, which is really nice. I'm all about cheap solutions. I don't need to buy a $1,000 chair. All right, so what we want to do now? So we want to say for row in range, say let's add 8 here. Let's add 8 rows. We're going to take grid, and we're going to append another list. Grid. So we're going to put a list inside of a list here. All right, and then for column in range 8, we're going to take the grid at the row index. So maybe I should say row index here. That's a little nicer here. Okay. So when this is 0, the grid at index 0 is this thing I had just appended. When I add a second one, I'm at row index 1, this will be the second one. Here I can now call append because it's the list. And now what I want to do is I want to add, let's add some numbers. Hi Jack. Thanks. Did you find my shoe? Thanks, buddy. All right, I was missing that shoe.
Yeah, look.
Yeah, I'm teaching class right now, buddy. You want to say hi?
Yeah.
Here. You want to say hi?
Yeah.
Here, wave to everybody. Say hi. They're on the computer.
Cool.
Yeah, say hi. No, don't grab my drink. Say hi. Okay, you gotta get going, okay? I gotta finish up class. I'll come play in a little bit.
Go good.
Go tell Mama.
Go good.
If you want a yogurt, go tell Mama.
Go good. Yeah.
Alright, so we've got our first row here. We're gonna start appending, and let's just keep some numbers here, I guess. Let's do numbers. We'll start off at 0.
Yeah.
So we're gonna append number, and then I'm gonna take number plus 1 every time. And then when I'm done, I'm gonna print the grid out. Alright, let's take a look. Alright, so here's my grid, right? I get the first row, right? The first item at index 0. Hey, Sammy. Oh, you're saying hi to Jack? Has numbers 1 through 7, or 0 through 7, right? Then there's another item. So this entire list is at index 1. This entire list is at index 0. This is index 2, on and on and on. But printing it like that's not always as pretty. So I want to say for row in grid, I want to print the row. Oops, and run. Okay. So now I can see that I've got all my numbers here, right? Up through 0 to 63. Right, just I counted up. So 8 numbers, and 8 more 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 numbers. So now what we can do is I can reference any one of those items by row index and by column index. I can get a particular value out. So which number here from 0 to 63 should we get? And we'll make sure we can actually go grab it here. And just for fun, we'll see if we can print it out. Which one of these numbers? You guys want to guess a number, or just shout out a number at me? All right, 23. So 23 is right over here. So it is in row 0, row 1, row 2. So my row index is going to be 2. So grid at 2, right? Grid at index 2 is this entire list. Now this list has its own set of indexes, and those you can think of as columns. This is column 0, 1, 2, 3, 4, 5, 6, 7. So grid at 2 at 7. So at row 2, column 7 should be 23. Let's see if we did it right. 23. Right, so you can kind of think of it as it's a two-dimensional list. A list of lists is a two-dimensional list with a row and column. Now, the only weird thing here is I know that in math land, when you learn math, 0, 0 is like in the bottom left, usually, the origin. For us, 0, 0 is at the top left because it's the first one. It's a little confusing, but don't worry too much about it. Just the first row, right, is at the top usually when we print because we do things in order, right? We don't ever print things. I guess you could print backwards if it really bothers you, but that's likely to confuse things anyway. Okay. So let's do this for fun. Let's build out a multiplication chart. So this was fine. This was some numbers here, but that was just an example. So let's build out a multiplication chart. Multiplication chart is a list. And now for number in range, let's go from 0 to 10. So we need to hit 11 to be inclusive of 10. We're going to check our multiplication chart. I'm sorry, this is the index, actually. Let's see. We want an index here. Oh, a nice stretch. Thank you. That's good on the back. All right, so for row index in our multiplication chart, from 0 to 10, we're going to append another list. So it'll give me a 10 by 10 list here, but these ones are all empty to start. So what I want to do is for the first one here, so if row index is equal to 1, or equal to 0, for the first row, I want to start adding some values. Right? I want to append in, and the values that I'm going to put in there are actually the row index. Sorry, if it equals 0. I'm going to take my multiplication chart at row index, and I'm going to append the row index. So that will set the first row up with 0 through 10 for a multiplication chart. Okay? Then what I want is, for every other one of these here, right, the else case, if it's not row index 0, all I want to do is add just one value, because I want to add the first value. And that first value is going to be multiplication chart at row index dot append the row index. So at row 1, or the second row, row index 1, I want to put a 1 in the top left. And we're going to have a bunch of blanks. And that's it. I'm sorry. If it's the first one, we want to do it for now. Number in range 0 to 10. 0 to 11. That's right. We're going to append the number. That's what we want to do. Okay, so this will give me all 10 of them, right? So this will give me 10 rows, and then if it's the first row, put all 10 numbers in. Otherwise, just put the first number in. Okay, and then we're going to say for row in my multiplication chart, print the row, just to see what we get out. So we should have a full first row and a full left line. Okay, we have the full first row, and we have the full left line. What we're missing now is all the actual multiplication now inside of it. So now we need to go fill that out. So now what we want to do is we need to loop through and figure out that arithmetic. Okay, so we're going to say for row in, or this is a row index in range. And we're going to start at 1 here, and we're going to go up to 11 because we want to get to 10. Right, so I don't need to do the first one, I only need to do the second one. Now for column in range, and now I already have something here, but there's nothing at index 1. I didn't add any zeros. Right? So I can't say I need an index number. I just need to be adding columns here now. And I need to do 10 of them. Right? Because we actually have 11 values here, right? With 0 through 10, that's 11 values. So we need to add 10 more values to each row. So what we're going to do is we're going to take my multiplication chart, index of the row index. So at this row, right, we want to append, and actually no, we do want this one to be a column index because we're going to reference the above ones here. That's what we're going to do. So we want to start at 1 and go up to 11. There we go. So this is the column we're going to be referencing above. So what we're going to append is we're going to append our multiplication chart at row index at column 0. Right? It will be the first thing. And I want to multiply it by the first thing in the first row. Does this make sense? Hopefully. Let's can I drop this down a little bit? Yeah. So I'm going to multiply that by, here, let me actually put that append back here. So append that multiplied by my multiplication chart at column 0, because I want the first one here, the column index. So for every row from index 1 to index 10, and then for every column from index 1 to index 10, I want to add in a value of this times this, and then this times this, and then this times this, and then this times this. Right? Stay in the same row, but keep changing the column index. Okay, and then we're going to print out our multiplication chart. I guess we could print it both times. Why not? This might hurt your head a little bit. The two-dimensional lists is a little bit crazy. Uh-oh. Oops. I had the wrong notation there. Sorry, not a comma. Not a comma. There we go. So look at that. So here's our chart. 1 through 10. 1 through 10 on the left. Right, the first row is the same, but not by 2s, counting by 3s, counting by 4s, counting by 5s, by 6s, by 7s, by 8s, by 9s, by 10s. Nice. Now if we wanted to make that a little prettier, right? Right, because we want to make things pretty. So we want to not print row now, so we want to say for, and now it's not really column, because it's really the item inside of that row. For item in row, right, we want to print. Let's print, let's do a formatted string here. Right, so we want to format, and I want the item, and I want to format it as a digit here, and I want to do some padding. So let's do, should we 3 padding? Maybe a 3 padding. Let's try that. See if that's, oh, and after that's done, then I want to print a new line here. We got to space separate these things, and then we'll change the ending character to that, and then we just print a new line after the row is done. All right, let's try it one more time. Uh-oh. Didn't like it. Oh, I didn't like invalid format specifier. Oh, I didn't like that one. %. Is it just D? All right, I'm going to go look it up because I don't remember. Python format string digit. Oh, we'll look it up digits. Colon. Oh, I don't even have to tell that. So just 0, 2. Okay. I don't want to put the D in. I'm confused. So just 0, 2. Is it just 2? Or we wanted 3, right? Let's try it. Yeah, there we go. Look at that. That's a much prettier chart now. Much better looking than before. So we're saying pad it to 3. So everyone is 3, and then I'm space separating after. And that way my 100 fits here. That's a much prettier chart. So again, the syntax here is a little weird, but that's okay. Don't worry too much about it, right? We just need to puzzle through how do I get the right index, right? And whether or not I'm appending something, or because we built it out empty first. We could have built it out with all zeros and then went and added and not had to do an append. We could have just done some arithmetic, but I think this way works out. Okay, and then you can also put a dictionary inside of a dictionary if you want. Same like you can have a list of lists, you can have a dictionary of dictionaries. And that starts to get a little bit silly, but we're going to play with that in lab on Monday. Okay? You guys feeling all right? Again, a virtual lab. I'll post the assignment. I'll hang out in Discord. You guys can ask questions. We can do screen shares if we need to. And then next week we'll pick up classes and we'll start our next project. For project number 2, we'll get a third project in, a third individual project or that's actually the 4th, right? We started with 0 because we're funny. Individual project in, and then we'll have the final project, and we're already looking towards the end of the semester. It's actually 2 months from today now. The final project is due. So hopefully someone you can look forward to, maybe. Hey, Blowfish, thanks for coming by. Friends of Multilingual Miracle. Yeah, we're just ending, sorry. Just wrapping up. Looking forward to the holiday break and winter semester that will look nearly identical to this. Labs will be fully remote as well for 2001 if you're continuing on in Python, and lectures will be on Twitch unless people say they hate it. And I'm open to suggestions. The class is for you guys. I just think Twitch is a fun platform. So let me know. Keep in touch. Please do reach out if you have questions, concerns, thoughts, right? And we can go from there. All right, I'll be hanging out in Discord for office hours after. Drop by. Let me know how it's going. Yes, yeah. Don't give us any good advice there, Blowfish. Definitely not allowed. I always appreciate you dropping by, my friend. All right, so I think we've rated most everyone else around this sort of time, so I'll just end. Go find someone interesting. You can give a shout out to the Knowledge Fellowship if you still want to keep learning stuff. Check out someone else's stream, have some fun, get a nice brain break, and do some interesting things. All right, and I'll catch you guys later. Take care. Drink your coffee.